Welcome and good morning, afternoon or evening to you all joining us from the United Kingdom, across Europe, the Middle East, Asia, Africa, the United States, Canada, or wherever you are in the world. My name is Marianne Dutka and I'm the Product Marketing Coordinator for Sealite, and I form part of our global marketing team. Thank you for joining us today for our fifth and final webinar in the Sealite series. We hope you have found our previous webinars truly informative, and if you missed them, I invite you to watch them back at your own convenience. Feel free to visit our resources page on the Sealite website, or you can visit our YouTube channel where you will find our webinars plus a whole range of videos that showcase Sealite and our range of innovative products. We are joined this morning by Simon Millyard, Chairman of the IALA Engineering and Sustainability Committee and former Engineering and Operations Manager at Trinity House. Our topic today is monitoring and asset management of AtoN. It includes the professional views of Simon, who has a long-standing marine career that began in 1973 with the Royal Fleet Auxiliary Service. Simon will discuss how monitoring and maintenance tools can be used to inform asset management plans, provide insights into how Trinity House use these tools to help them to achieve their high AtoN availability targets. In this presentation, Simon will cover monitoring and asset management types, asset management and maintenance, failure mode effects and critical assessment, and practical examples from Trinity House. Before I pass over to Malcolm, I'll just quickly run through some housekeeping for those that are not familiar with the Zoom platform. To view the speakers today, under the View Options tab at the top of your screen. Feel free to ask any of your questions using the Q&A box during the webinar, and you can access that from the bottom of your screen. I now pass on to Malcolm, who'll discuss our webinar series.
Thank you very much, Marianne, and what an absolute pleasure and delight it is to have Simon with us this evening. This is our final webinar in a series of 5. And as Marianne says, you feel free to go to our website and view the others if you haven't already. It's absolutely fantastic to see so many familiar faces in the participants list. Welcome and to you all. And without further ado, I'd love to take the chance to introduce Simon. Marianne said he began his career in 1973 with the Royal Fleet Auxiliary. First class certificate, competency 10 years later, good job. And then he spent a little while out of the industry, but an industry that is familiar to all of us in the brewing industry, selecting, tasting, brewery manager of Green King Brewery, which is a fine ale. But the Call of the Sea brought him back, which is absolutely fantastic and lucky for us. He became a chartered engineer in 2011. Unbeknownst to me, thank you, Simon. And I've had the pleasure of working with Simon since he joined Trinity House in 2008, formerly as my boss in Trinity House, but laterally as my chairman of the IALA Engineering Committee. So with that, I'd like to hand over to Simon to give you this presentation on asset management and monitoring.
Thank you, Malcolm. Well, good morning and good afternoon, good evening to everybody, and thank you for joining us. And thank you to Marianne and Malcolm from Sealite for inviting me to present on this. I've been in maintenance and engineering delivery all my working life, so I hope this is a summary of my thoughts relevant to AtoN navigation, and I do hope it is of interest to you. Just a quick recap as to why we're here. Why are we talking about asset management? And it's regarding the AtoN availability requirements set out in IALA. And we have the 3 categories: vital, important, and necessary. You will probably be familiar with this, but that's what we're trying to achieve. But of course, it all comes at a price. And if we want 99.8% availability, then we have to design and maintain to support that. And if we are, content with category 3, then that is less onerous. The guideline on IALA availability goes on to say that if you cannot achieve 95% on any AtoN, then you should consider taking it away and replacing it with something more reliable. Because if the mariner turns up into your waters, they're expecting to see the AtoN working, and 95% is the bare minimum. But the overriding issue here is to maximize availability and minimize the cost. So what do we monitor and what do we control, as it all comes at a price? And any monitoring you do, because it's expensive and it does impact your performance, should be the outcome of a risk assessment. And again, how keen are you to know how your AtoN are working at any one time? And again, we'll come on to that in a moment. But do remember that monitoring itself does not improve the AtoN performance. All it does is tell you how it's performing, so you can respond quicker and therefore improve your AtoN availability in response to a failure. And of course, there's various options on monitoring, which we're going to run through now, from the very basic to the more complex. So we can have user monitoring. And so here's a very prominent lighthouse, and it's just a bit of a rather sad but informative picture. So user monitoring relies on the mariner informing the Coast Guard or local authority that an AtoN is not performing correctly. And it has its place in some areas. In this particular example, actually, it wasn't an AtoN fault. The ship was at anchor in the bay and it broke its moorings, and the engine was being repaired, and she drifted onto the rocks, unfortunately, just underneath the lighthouse. You've got a little quiz here. I'm afraid there's no prizes, but if you'd like to guess where that is in the world, then please put it on the chat box, apart from Malcolm, who should know this straight away. So that's user monitoring. You're relying on the user to phone in. It doesn't cost you anything, but it is purely reactive, and but has its place for some base navigation, but probably not for many. Another one is observers or lighthouse keepers, and here we have the fine band of last lighthouse keepers for Trinity House in 1989 at North Foreland. And observers, you can have lighthouse keepers who are paid full-time, living on or close to the lighthouse, or you can have part-time paid observers whose job it is to check the light every night and telephone in. So it's seriously up from user monitoring. Another sort of slight advantage of having lighthouse keepers, which in many authorities have disappeared, it does provide employment, and it has a bit of social cohesion for the area. So it shouldn't be dismissed as archaic. There is a social benefit to this system, and is still employed in some areas of the world. But 1989 in Trinity House in England, that was the last. That was when the automation program was completed. And then we move on to automated monitoring, and there's various options which we will talk through in a moment. But we can use AIS, automatic identification system. We can use a proprietary system from a supplier, or we can use a bespoke system using mobile phone, satellite phone, or radio link. But any system that you use will have three components. It will have a back end or a remote terminal unit, often referred to as an RTU, and that will be sited on the AtoN. And then it will have a front end to alert the authority of any issues. Now, this may be on a complex system, it may be a big screen, it may be web-based, it may be a text message that you get on your phone, but it will be a system to alert the authority or the user or the organization maintaining them. And the third component is a means of transmitting the data from the AtoN to the alert system. So a quick look at AIS, pros and cons. They're relatively cheap to purchase. I know you'll all be dealing in different currencies, but probably about $4,000 or $5,000 for a system. It's free to use, so big advantages there. But it is running on unsecured VHF, and it is limited in range to VHF, which is generally line of sight. You can extend that by chaining from one to the other. that brings issues of complexity, but you can do that. But again, you need a front end to interpret the message that will give you the monitoring data, which would be message 21 or mainly message 6. And they come in various guises. Here's an independent unit shown on the picture, but you can get them now tucked into the lantern itself. But again, you generally get what you pay for, and the bigger and the better the antenna, the longer the range you're going to get. Here's a proprietary monitoring system. Picked out the Sealite one, but many manufacturers will offer, when you purchase their AtoN navigation, they will offer a system that you can use to monitor. Some it comes free, others you subscribe. It's generally web-based. And here's a little graphic from the AtoN up to the satellite down to your front-end screen. It's generally managed by the AtoN provider. So the Sealite perhaps would manage this system for you. So if you purchase the AtoN, you can then dial in and see how it is performing. And from that, you can draw down availability data. Just a word of caution though, be careful to select a supplier who's in it for the long term. And there are examples of proprietary monitoring systems who companies purchased and they worked really well. And then that AtoN supplier either went out of business or decided to withdraw the product or were taken over and the product was withdrawn. Then the AtoN, authority then is left without a monitoring system. And you've invested a lot of time, a lot of effort and emotional effort into this, and suddenly you haven't got it. So just beware that you pick a reputable supplier who you believe is in it for the long term. Then you can have a bespoke monitoring system. This would generally be using a SCADA system. SCADA will come onto in a moment, simulation, control and data acquisition. And the photograph here shows the Trinity House monitoring center in Harwich, England, with the various screens monitoring a range of AtoN, also for some other AtoN authorities as well. And that is staffed 24 hours a day. And of course, the main issue here is it's expensive. But the advantages is it's very comprehensive. You can control as well as monitor. So if you want to turn off one light because it's becoming unreliable, you can turn on the second light if you have one. You can start a diesel engine remotely if you wish to. And from a comfort point of view, if the technicians are going off to a lighthouse in the middle of winter, you can turn the heating on a week in advance. But it all comes at a price. Big advantages, you have control of any obsolescence, so you can update it and maintain it and keep it modern. And you can design it as you want it to display, and you can get it to alert what you wish. You have control over that. So that probably is the going from the user monitoring to this bespoke monitoring system covers the range of monitoring options around. Just for information, we spoke about the remote terminal unit. So here's a large navigation buoy, a Trinity House buoy. And in here is the control terminal, the control unit, which sits inside one of these, where it's got the name of the buoy there behind that panel. And the blue unit is the RTU, the remote terminal unit. It says S2000. And up here is the SIM card, which sends the data out on a mobile phone. And I'm just going to move excuse me a second whilst I just organize my screen. And over here is another comms method, communications method going through satellite. And I'll talk about that in a moment. But we had a particular problem with communications in that the navigation buoys that were close to the shore could pick up a mobile phone signal quite easily. But the ones that were 30, 40 miles offshore could not. But satellite communications are expensive. And this unit was designed to search for a 3G signal using this SIM card here. If it found one, it would use it. If it couldn't find one after 3 attempts, it would flip over and go to satellite. So we had a complex system, but it saved a lot of money because we only paid for satellite comms when we had to. So that's an example of a RTU on an AtoN. So there's always a risk of getting carried away when you're deciding what to monitor. If you have too much in there, you will run the risk of getting false alarms, and you waste a lot of time and money following up on monitoring issues rather than AtoN issues. And you'll dispatch the ship out to a buoy only to find that it's the monitoring antenna or the monitoring system, and the AtoN's working perfectly. So just be aware, and you really only want to monitor the bare minimum. Is probably the most reliable. So there's a slight risk there if you get carried away at the specification side. And what you monitor, well, the choice is yours, and there's a list of things you can monitor. It's and on it goes. The more sensors you have on the AtoN, the more you can monitor anything you wish. But it's a question of picking what you think is important, and that will vary, as we will see later on the asset management component. If the station is very hard to get to, and it's going to cost you $10,000 to get out there by helicopter, then you may be more interested in monitoring in detail so that you know what you're going to be finding when you get there, rather than a station that is half an hour's drive up the road from the office. It might be cheaper to take that half an hour drive than it would be to put a very expensive monitoring system on. Here's that buoy that we saw earlier on, and I just included this picture to give you an idea of the size of it. You see the crewman on the ship there, and the size of the buoy. It's a big old piece of kit, and this is within Trinity House is the most sort of comprehensive floating AtoN outside the light vessels, with a 7-mile light with AIS. It has a Raycon. It has position monitoring, such that if it goes off position outside the guard ring, it will automatically turn off the Raycon. It has GSM communications and satellite communications. So it's quite a comprehensive piece of kit. And these are the items that we will monitor on that buoy. But again, as I say, that is our most comprehensive of our buoy fleet there. Now moving on to asset management. And this is a term you'll see banded around, and you'll see many books written on the topic. And it's really the sort of, it's a posh way of saying, you know, taking an interest in and taking care of your assets. And you're looking for the long-term care of your assets at optimum cost. If you've got the money, it's easy to throw it at the asset, but it isn't an efficient use of your money there. You need to try and optimize what you're spending. And asset management and maintenance, they go hand in hand. And as we'll see in a moment, different AtoN will require a completely different asset management strategy and maintenance plan. And so here's a nice, well, actually it's a rather grainy picture, I'm sorry about that. That is Longship's lighthouse off the southwest tip of England. And judging by the sun on it there, it's in the evening sun. And it looks like the helicopter's just leaving it, and that's the coast of England behind it. And you think, oh, that's a nice little lighthouse, wouldn't mind a trip out there. It's only a short hop from our base, you know, a 5-minute helicopter ride from our base. So there it is on a fine day. And here it is on a not so fine day, taken with a zoom lens from the mainland. And so your opportunity to get out to Longships is not guaranteed. We get green water over the top of it from the Atlantic swell coming in. And you get the helicopter to fly out there and you find half the helipad is missing. So you've got to choose where you land. because the green waves have taken it. So, you know, that requires a very thought out asset management plan for how you're going to maintain what you're going to maintain and how often you visit there. And then you compare that to, this is Southwold, a beautiful seaside holiday resort on the East Coast. Hour or so's drive up from the main office from Trinity House. You can drive up there, have a cup of tea on the pier and a fish and chips and a cake, and then wander down to the lighthouse to do your maintenance. Very different challenges to that one. Although interestingly, there is a very high quality brewery just behind there, and their chimney from their boiler room does produce some deposits on the lantern glazing. So, you know, you wouldn't have thought that, but again, ask the technicians and they'll say, oh yes, yeah, you go there, you need to clean the glazing. So that has different challenges, whereas on on Longships, the sea cleans the glazing quite effectively of its own, as we saw. So traditionally, when you got some new equipment delivered, you'd read up what the manufacturer said about the maintenance program for it, but like the service interval on your car, and then you followed that, and that was what you did. But most of these were around the calendar. You know, they were written around the phases of the sun or the moon. And really, as a race, we should have moved on from that by now. And I would propose a more tailored approach to maintenance rather than following exactly what is said by a supplier or a manufacturer, because each AtoN is in a unique position. Whereas many, say, buoys would have a common approach, but each lighthouse certainly would benefit, I would say, from a tailored approach. And we would start using the FMECA approach, failure mode effects and criticality assessment. This is where if you were running a nuclear power station or a pharmaceutical business or something, you would do this down to component level. But here, in the AtoN business, you probably wouldn't. You might do as a manufacturer. Malcolm may choose to do this when they're designing a circuit board or something. But for an AtoN authority or an AtoN provider, you know, sorry, as a competent authority delivering ACE navigation, you would look at systems and say, well, if this failed, what is the mode it would fail in? What is the effect of that failure? And how critical is it? And you would go through that for every system that you have, or every leg of that system within your AtoN navigation. And from that, you could then decide where you wanted to place your attention on the design, the installation, the maintenance strategy that you would use. And of course, many people do this subconsciously anyway in a range of risk assessments in daily life. But the FMECA approach, you would document it and record so that it supported your decisions as to why you were doing this on your lighthouse every year or every visit. But as we said earlier, many buoys have the same issues, and they would probably be a common approach. But many lighthouses and fixed AtoN have different issues, and we've touched on them. The access challenges and the cost of access. Is it $10,000 and you're at the mercy of the weather when you can get out there, or is it a 1 hour drive up the road for, you know, with a cup of tea? That is a big issue on accessing ACE navigation. Another one is equipment age, and obsolescence is becoming a really big problem. And equipment, you know, and it's getting worse. 10, 20 years ago, obsolescence, you sort of saw it coming and then you could deal with it. Now it comes at you left of field, unexpected, and you've got a complex system which, you know, 10 years ago was the height of complexity, and now one bit of it is obsolete, and you're in a bit of a struggle there. And an example of that is we're using the metal halide light source quite commonly throughout our lights. We knew they were due to come to an end, and we were replacing them slowly with an LED light source. But they were fine, they were working, and within our sort of 20-year rolling modernization program, they were due to be phased out. And then all of a sudden we get 2 years notice that within Europe, they are being banned from sale because of their poor efficiency, you know, light for electricity. So we suddenly had a problem. So we then had 2 to 3 years to change out the light sources in a large proportion of our estate. So obsolescence comes out from a range of areas. It isn't just the manufacturer is no longer making it. It can be a legislative imposition. Other areas, geological, you know, we have some are subsiding, some are subject to flooding and sea level rise. We have some lighthouses in a granite rock area where we monitor for radon gas. So everywhere is going to be different. Some have a challenging environment, as we've seen in the pictures. And within IALA, we did we had a workshop on you know, extremely hot and humid areas, and the challenges you get in the tropical and the Gulf areas are immense. Trying to, and also equally in the Arctic areas, and you know, in the polar regions. And of course, some lighthouses will have other criteria, which they may be a visitor centre, so it may be open to the public. So therefore, we want it to be presented in a very, you know, to show the organisation in its best light. Whereas if it was on a remote area, never visited by the public, you would be less concerned about the image of it. So then you've done your failure mode effects and criticality analysis, and you're going to come up with a mixture. You're going to have some routine calendar work based around the phases of the sun and the moon. Why? Well, sometimes you're driven to it. For example, if you have a lighthouse that is occupied, you may have fire extinguishers on board or fire detection equipment, and that may have a legislative requirement to be tested, inspected annually. Therefore, you have to do that. Others, it might be convenience. You're going there and you have an annual budget cycle, so annually seems to be convenient. And if you're going there and it's expensive to get there, you might as well do some work whilst you're there. You will have some inspection work to assess the condition. And some items are best run to failure. I haven't put it up on the screen here, but many of you will be familiar with the bathtub curve of failures. This is a sort of classic prediction that when you buy a new piece of equipment, it is more likely to fail than when it's been bedded in and running well. Then you'll have a long, long time of good performance until it starts to wear out, where you start to get some failures. So if you can get over the initial bedding in period, then you're pretty confident of a long run of high performance. So over you know, 2 decades, you may well get better performance from some items if you run them to failure. And that is as long as you've thought about this, and that is you know, your strategy, that is understood. Probably not a good strategy on a lighthouse that you can't guarantee to get to. But if it's just up the road and you can get to it in an hour and fix it, then that could be an economic strategy. But I would avoid intrusive maintenance if at all possible. If you don't have to take it apart, don't. And there are many examples of maintenance-induced failures. I remember some years ago, I was taking the directors around to show them the estate, as we do periodically, and we got on this lighthouse. All was good, so we decided to put it through all its failure modes. So we killed the power on this and turned the lights off on that, and everything else jumped into life, and it was all going very well. And then we decided we turned off the main light, and the second light came on. It's fantastic. Then we turned off the second light, and the emergency light came on, and it was fantastic. Except the emergency light was flashing the wrong character. Oh, how embarrassing was that? And that was because at the last maintenance visit, the wisdom of the day was you put the emergency light on to permanent on, measured the current to check the current was all good. Then you put it back to its flashing code, and the dip switches had been put in the wrong position. So the wrong code was being flashed. But, you know, really, was it necessary to check the current on the emergency light when it was working? You know, that's a matter of debate. But the end result was a maintenance-induced failure. And your visits will also include some corrective maintenance that were found on the previous inspection visit. I just put a picture here of my colleague Dave changing a MBI light in Wolf Rock out in the Atlantic. And a nice little picture there. It's just I spent a week out there. That was very interesting. And then how do you arrive at the best plan? So you've done your FMECA analysis. You've considered all you want to consider about access challenges. This is what you need to get on the table. You need to look at the required availability, your current performance. And if your current performance is sparklingly good, then either leave it alone and carry on doing what you're doing, or you might have an opportunity to cut some of your costs down. Look at your historic failures. What were they? Why did they happen? Can we stop them happening again? How expensive is it to get there? Because it does vary. And how reliably can you get there? And how robust is the design? Look at your spares usage, because that can be quite telling on how many, are you using up lots of one particular item, and if so, why? But above all, I would say, talk to your maintenance staff. That, in my experience, has been the most valuable source of information. And I remember one organization I worked for some years ago, we had a new computerized maintenance system in. So we were all spending hours and hours pumping information into the computer. And then the powers that be came to the site and said, we've cracked it. It was like the answer to the ultimate question. And your main problem here is this hydraulic spool valve. And all the maintenance technicians said, yeah, we know that. We've been saying that for years. So talk to your staff. And, along with other information, you will then get a sound rationale to arrive at your best maintenance and asset management plan. You can have a computer-based management system. They come under various names. MMIS, Maintenance Management Information System, is a common one. Most organizations have one, but they can be very expensive. They can be very expensive to buy. They can be very expensive to train your staff and then manage them. And do look at the small print, because after you've spent a lot of money buying it, you've then got the license fees to pay. And just check on the license fees that the license fees will have an inflationary increase every year. And that could be in the small print of 10% or something. So you start off on what you think you can afford and find you're tied up to this thing with a 10% inflation cost year on year. So do be careful. So you need deep pockets to run a all singing, all dancing computer-based management system. But you can, however, run a small organization on a manual T-card system. You don't have to pay for an expensive maintenance management system on a computer. It may sound archaic, but it's very cheap. It wouldn't, you'll never get hacked, and it always boots up every time you walk into the office. There it is on the wall. And also, there are some very good low-cost computerized work planning systems that will give you good data and provide a diarized work order system for you to use. And there are some very cheap ones around. They're very effective. And I would counsel that if you're going to invest in a computerized plan maintenance system, I would urge you to buy a small one at a modest cost and use it to its full, rather than buying a very fancy one, very expensive, and only using 10% of its capacity. Because the more expensive it is, the more you've got to train your staff in generally how to work it. And moving on to the traditional condition-based maintenance, and this is very prevalent in factories and manufacturing process industries, things like electrical thermal imaging, which is invaluable for fault diagnosis and predicting failures in a factory. along with other ones. I put them there: oil sample, vibration analysis. There's other ones. They're commonplace in factories, but I don't find they have much value in the AtoN arena. The sort of equipment we have, they didn't find much of a place. And as we said earlier, if you're going to spend £10,000 getting to a site, then you might as well change the oil on the engine for next to nothing whilst you're there. Now, just to have a quick look at the Trinity House model, which we developed over the years and has held the estate in good order. So every asset that the Trinity House owns has a risk and opportunity register. So this is a one-page piece of paper identifying, well, what risks are there on that asset? And they might be the geology, it might be obsolescence, it might be that we lease it and we don't own the lease, and will the lease be renewed? It might be that it's got some problems to it, it's falling down. And then each asset, we have a 10-year asset plan, which includes the major modernizations and when they're due. And again, each asset has a page, and I'll come on to an example page in a moment. And then as the years roll on, you get into a 2-year plan, which has detailed plans, designs, and costs for the next modernization. But of course, within that, there will be annual or twice yearly maintenance visits. And for a visitor center, we may have a monthly visit by a local attendant. And every 3 years, we have a building condition survey, which looks at the structures, a structural survey on the site, looking at the condition of the structure. There's an in-year plan, so in the current year, that will be showing all the resources allocated to each asset, including the planned maintenance visits, the corrective maintenance visits, and any major modernization visits that are scheduled. And each asset has an asset management plan. So we have this sort of strategy and the schedule above there, and the asset management plan, and that includes, for relevant people to look at, what your maintenance and inspection schedule will be, historic running costs, and that will flag up, well, why is this one so much more expensive than that one? And you need to take that back probably over 10 years, because for Trinity House, every 7 or 8 years, you would generally paint the outside of the structure, and that would skew those years' costs. So you need to include any repeated significant costs. And you'll also include previous modernizations and future plans and any risks and opportunities for the site. But generally, every 20 to 25 years, every site will get a major modernization. So here is a typical page from the 10-year asset plan. And this is a lighthouse on the east coast of England, a rather snowy picture there in the depths of winter. And this page here gives you a little bit about the station, and this is signed off by the Director of Operations, one for every page, which is an annual event, so that we keep an eye on what's happening, and the Director of Operations will have a feel for, actually, there's an AtoN change coming up here. Do we need to make changes? Every 5 years, we have an ACE navigation review around the coast, and this was last done in 2015. It tells you a bit about it when it was built. This one is Grade 2 listed, which in England is it's a protected building. It's also, part of it is an ancient monument, which is the highest grade of protection a building can have. So that tells anybody going there, you can't just screw an antenna on the side of it or repoint it when you fancy. It's a site of special scientific interest. It's a special protection area, so it's a highly protected site. A bit about the light, references to all the asset management plan, the property profile about who owns it, what access rights we have, and the structural report. And here we have a little fishbone diagram from the last time it was modernized in 2008 up to a notional 20-year life. And then what we're thinking that we will be doing in those 20 years. No dates, but here we have, remember we spoke about the S2000, the remote terminal unit on the Buoy. Here, there was obviously a view that we're going to fit an S2000 to replace the one there at some point. And we're looking at this is the lantern, the light that we think is going to go obsolete, and we're going to fit an LED. So every lighthouse, every asset has one of those. So here's a beautiful lighthouse in the Channel Islands of Sark, and 3 years ago this had a rotating optic, first order optic, rotating on a mercury bath, but mercury had to go, and here we fitted a main and standby LED lantern, and much cleaner, less moving parts, no mercury. So that was, but of course it all has to be designed and delivered to the site and done on a remote island. So, Trinity House has a large mainframe computer-based management system, which we use for work planning, recording work, recording performance. It is expensive, and it takes time it took a lot of time to put in. It takes time to run. It does generate good reports on performance, and it is a very good database for the equipment that we have. And it is very good at diarising work orders and feeding that back in. I would say it isn't used hugely in influencing maintenance strategy. I still think that is more from feedback from the maintenance staff and the experiences of how it's performing, rather than, don't buy a system and then expect to turn the handle and out pops the answer to how to maintain it. That has not been my experience, but you will be told that by the people selling it, but that's not been my experience. And I just thought I'd add this in here because my wife never really understood the pressure I was under at work. And so there's a few clips from my time at Trinity House on some of the most beautiful parts of the country, working with a fantastic team of clever engineers, and sometimes having a bit of fun. But I say I never got any sympathy from home, but there we go. So back to you, Malcolm, I think, if you would take the screen back. I hope that was of interest.
Absolutely. Very interesting, very in-depth. And I love the fact that you have a lot of knowledge of process and procedure, but you're a real practical guy as well, and apply that practical knowledge to these processes, which is great. And I would certainly echo, listening to the maintenance staff is second to none. It really gives you a valuable insight. We're now open for questions and answers. We have had a couple of questions come in. In fact, we've had 2 questions come in which are more or less on the same subject. One from Africa and one from our good friend at the US Coast Guard. I won't translate the African French, but I can read Dave's question. As AtoN signals begin to move into the realm of the Internet of Things and are equipped with communication equipment such as VHF, cellular, satellite, all these kind of things to enable monitoring, how do we see AtoN authorities building cyber security requirements into monitoring system, and what do you think the role of IALA is in developing these requirements?
Wow, well, that's a really good question, and one we wrestle with. Just very briefly, the VHF from AIS is unsecured, so that is open signals to be read by anybody. But it is monitoring; it's not control. So, so what if someone else sees what your battery voltages are? For the Trinity House system, it has a very comprehensive firewall. So all the data that comes into the Trinity House monitoring system will come either through satellite, GSM, or landline, or from a private radio network that we subscribe to, although that is being phased out. And it then goes in through a comprehensive firewall at the office to try and stop any rogue information coming in. But yes, you're right. It is always a concern. If you can access something, then possibly someone else can. What is IALA doing about it? Well, we had an AtoN cybersecurity workshop planned in Quebec, I think,
Yep.
last year, but that has been postponed due to the virus. So that will be reconvened, but I haven't got a date for that quite yet. So it is on the topic. It's on all of the committee work plans to look at and consider. Yes, the more comprehensive we get on IT, the more vulnerable we get as well, it seems. But yes, good question.
Yeah, it's a little bit chicken and egg, because you want to try and make things as open source as you can, but at the same time that opens you up to a lot of cybersecurity threats. So I think there's probably a balance in there. Now, next question, pretty straightforward one, and it's a yes or no almost. With modernization, does maintenance cost go down?
I think maintenance costs probably don't go down, but your overall costs will, because you are not paying for lighthouse keepers and the keeper reliefs and things. So overall, the cost of running the operation will go down. Direct maintenance costs for that particular button probably won't, but other costs, in fact, they probably will go up, because you've got to then go and access the station a bit more. But your overall costs will definitely come down.
Now, I'm not going to put you on the spot. This is an anonymous question. Very informative presentation. Thank you very much. In your experience, what is the cost of a computer-based maintenance software system? You know our audience, Simon, that they're always going to ask about cost.
I will do my best to give a straight, non-political answer. Don't quote me, but and maybe if I talk in US dollars here, because I can probably convert that in my head from GB pounds. You can pay anything if you start at a cheaper end, and when I say cheap, I don't mean poor quality. I'm talking about a low-cost basic maintenance package that would run 200 or 300 AtoN for you. You could get quite a nice little system for $20,000, and you buy that and it's yours. No license fees. You bought the disk. You can, if you wish, pay for a support package. At the other end, you can pay probably, $700,000 to get a big system up and running, but that will have a $70,000 annual license fee with inflation built in. So it's a bit like saying, well, how much is a car? You can get a cheap one or you can get an expensive one. But you don't have to get an expensive one. I think that was the message I was trying to get across.
Yeah, and that would be like an asset management type system, something like Sage or Oracle or SAP, and you can look at the various bits and pieces. And I guess it goes a little bit hand in hand with what we were talking about monitoring systems, the different technologies. How do you interface your monitoring systems with your asset management system?
Yes. Yeah. I mean, you need to sit down with it. You get the data off your monitoring system, and then you need to sit around the table and try and see if you've got any clues that will guide you to an improved maintenance approach, so that you're not you're only maintaining where it's appropriate, and you don't want to over maintain things, because that will lead to cost and probably unreliability. And of course, you don't want to under maintain things, because you will get poor reliability, and you will probably end up with a very poor quality estate as the years roll by.
So, yeah, short-term cost for long-term gain. I think that's about all the time we have for questions. You and I could, and I'm sure most of our audience could talk about this topic for hours and hours on end, which we have done in the past. But that does indeed conclude our webinar series. From the first webinar presented by me, where I gave a high-level overview of all the topics that we've discussed. And I'm actually quite pleased to see that they were covered more or less as I'd said. Then we had the pleasure of Roger Barker discussing risk assessment in more in-depth detail. Then we had Dave Leewald from US Coast Guard, who talked to us about the various systems and development systems and maintenance. And then, of course, we had Francis, who is on the call at the moment, discussing the role of IALA and their vital role. And then Simon, I think, has really, really wrapped it all up together, looking at essentially running an aid to navigation system, how you go about monitoring it and maintaining all your assets. So it's been an absolute delight and pleasure on my part to have hosted this and to have the pleasure of such great and fantastic speakers. And look out and beware, because we will be doing some more of these in the future. I think we'll look at some more practical applications in the future, but we will certainly be doing another webinar series in the future. So thank you very much for all the attendees. It's been a great series. Thank you very much, Simon.